Welcome back to the channel. Continuing on with the Ecoboost Ranger build. Going to be going over on how to build a custom intercooler today, so I'm going to dive into that. So this Ranger needs a custom intercooler. We have a custom radiator coming from Griffin Radiator, but we're going to build the intercooler ourselves. Here is a core. It's a CSI intercooler core. They're available from Summit, Amazon, all sorts of other companies. If you go to CSI's website, they'll give you the dimensions and the horsepower rating. This one is rated for 700 horsepower, which is a bit overkill for this engine, but it's going to fit inside there pretty well. And I'm making this video because when I kind of did a little bit of research, I didn't see a whole lot on the basics of making a custom intercooler. So yeah, you can buy the core off of Jeg, Summit. You just search the part number once you find what you want on the CSI website. Excuse me, this is a CSF, not CSI. So back to this guy. Got the core. It's really a complicated part. This one cost me 200 bucks, so it's really not that of an expensive start. I mean, you can get your cheap eBay intercoolers, blah, 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 and make them fit, but I wanted something decent that actually was better designed for my fitment. And I mean, it's twice the size of some of those eBay intercoolers. So anyway, once you got the core, the next step is the end tanks. You can design those out of cardboard, but I had all this stuff designed in CAD. So I had my end tanks laser cut and formed. So let's see here, kind of like this guy right here. That'll fit right up in there. TIG weld the joint. We got some 2.5 inch tubing to run for this. We'll have to go get some bees formed into that. And this here is the hole that it's going into. So it's going to be right in the center there, and there'll be some mounting tabs top and bottom on each side, and it will kind of fit in this space right here between, so we really don't have to cut a whole lot out. The radiator's going to be right in here, intercooler right here. We're going to have plenty of room to clear everything, hopefully. So if you don't have CAD program, it's really easy to do this stuff with cardboard. And just get some solid cardboard, start tracing it out. That's the nice thing about cardboard, is that mess up the first time, you just toss it, grab another piece, make a new template. Once you have that template, you can lay it down onto some aluminum, cut it out, and then you have your flat piece like this. Bending a little bit harder, but you can still figure out ways to bend it. You can stick it in a vise here, bend it over. You can find a piece of metal like so to roll it against to get your radius. There's all sorts of ways to do it by hand, but definitely, I mean, there's free CAD programs nowadays that you don't have to have your $5,000 CAD program to do this stuff. And I just found a local company that does metal work. I have to put in the price of what it ended up costing for these parts. But it wasn't too bad, especially since I just sent them the file. They cut it out and it's all prepped, ready to go. So you can also probably do this stuff on a plasma table, but I know that your kerf and stuff, your fit and finish wouldn't be exactly the same. A lot better on a water jet or a laser table, higher quality stuff. So now we got these parts all ready to go. We'll start laying this out on the bench, probably get something down so we're not messing up the fins. I can't really weld on this towel because one, will probably catch on fire, and two, there's not grounded to my, it's an insulator for my table. So we'll probably get something so we're not damaging these fins, and then start tacking these up. I need to scuff the stuff up a little bit and clean it with acetone, and we'll get stuff tacked on there and see how it fits. Little editor's note here for the material I'm using for the end tanks on this intercooler. It's a 190 thou aluminum 5052. Went with a little bit thicker, so we didn't have any ballooning of the end tanks under high boost, 35, probably not 40 pounds on this setup. But anyway, if you go with the thinner material, you might get some swelling of the tank. So just want to give you a heads up on that. So the intercooler is starting to take shape here. Tacked all the plates in place here. Once we get that all welded, we'll work on the intake and outlet tube. But right now, got it all tacked up. So we're going to test fit it into here to make sure everything's kind of lining up. We don't have any of the brackets or anything on here, but that'll come later once we finish welding all this. But we'll just kind of get a good test fit, make sure it all kind of looking how I want it to, and then we'll start welding it up. Fits between there. Have to do a little bit of trimming. So we're gonna get to welding this up. Some people will do inside and outside welds, but the way I have this set up is that the inside corners are just touching. So you're gonna get a nice deep penetration all the way through without having to go back and weld from the back side. We'll definitely leak test this afterwards, but if you were to butt those up, kind of like a lap joint on the outside, you're not gonna get as good a penetration, but this is gonna get the best penetration. One downside is I have an air-cooled torch, so I don't think I'm gonna have to be able to do the whole thing at once. I'll definitely be welding a bit, it'll get hot, I'll let it cool off, and then come back and do more. I do have a Miller Syncrowave 200 and it has pulse. I play with that a little bit on my surge tank there. So we'll get to going on this, see how it goes. Let's see, where do I want to start? I think we'll start on the other side. So this might be pretty tricky in here since we got different pieces of metal, might be heating and cooling. So we might save that for a little bit later, but we'll start out here, see how we get going. Of course, we managed to dip our tungsten here, but definitely not experts at this. Probably need a larger filler rod. We got 3/32. Probably should have 1/8 inch, but that's what we're gonna work with. Try welding that seam there, traditional, and then we'll do pulse on the outside here. the noise. Got the welder going a little warm. Torch is definitely warm. I'm gonna let that cool down. I think it's kind of off-gassing some brazing material. That's why it's kind of, smells a little funny. You can't smell that, but it's kind of not the best weld along that. We'll let this cool off, let the torch cool off, and then come back and do more. Went ahead and got these mounting brackets tack welded on the intercooler, not fully welded yet. I want to go ahead and toss it over into the truck, make sure everything's going to work before I fully burn them in. Got the intercooler set in here, adjusted how I want it to. It's all fitting pretty good. I had to do a little bit of clearance. There's an upright right in here, but I got it all nice and flush against there. Brackets look like they're going to work out well, so I'll go ahead and pull this out and finish welding those. Alright, so this side's all welded up. We'll end up grinding this down because it actually sets above the mating surface here. So we want this all flat. So I'm going to flip it over. Probably end up welding my gussets and then probably do some beads on the other side. So when we grind this down, there's a little extra meat on there on the weld. So got the welds all ground down so it's nice and smooth across here so we're not bumping off the mounting surface with the welds. Gonna go ahead and bolt this into the Ranger, or at least drill the holes so it's all figured out, and we'll pull it back out and start welding in the inlet and outlet tubes. Intercooler's installed and fits pretty good. Drilled some holes in the core support here, fits in there pretty good. Gonna pull it back out. Got these inlets and outlets test fit in here, and we rolled some beads on there, so I'll show you how that goes. Also got this sensor port welded on here. It's the factory forward boost pressure and I think charge air temp sensor right there. So I'll give you a better shot of that. But anyway, gonna get this pulled back out and weld these guys on here. So this is the tool I use for rolling the beads on here. Got it off of Amazon. It was about $125, $130. I'll go ahead and put a link in the description. It came with a nice carrying case, so when you toss it in your toolbox, it's somewhat organized. So pretty much the process for this is you stick it on this lower mandrel and then you rotate it around. It runs it around and creates the bead. It's definitely a slow process. You don't instantly clamp it down tight and make the bead the first go around. You do slowly progress it and keep turning it around. You don't want to tighten it down too much where it's hard to turn. Just it's a slow process and you'll eventually end up with a decent bead to work with. Just keep tightening it down until you're happy with the bead. I think this one will go all the way down to 5/8, and then 0.65 is the maximum wall thickness it'll work with on aluminum. So definitely a good tool to add into your toolbox if you plan on doing a lot of this stuff. Better than welding beads and then turning on a lathe. So we'll get back to welding these on another intercooler. Alrighty, so there you have it. Those are fully welded on there. It's pretty much done. I think the next step we're going to do is figure out a way to cap this up and do a pressure test in a bucket of water or tub of water, check for any leaks. Alright, so we got the intercooler set up here. Made some quick plugs, quick and dirty, to plug up the end of the intercooler here with rubber couplers. Just some round tube and some scrap flat aluminum. This one over here I drilled and tapped for this air fitting, so we'll be able to charge this with air. I don't have all the T-band clamps, so went ahead and just grabbed some regular hose clamps. We'll get this all clamped down and stick it out in the pool of water and test it for leaks. So for the dunk tank, I got a makeshift setup here. It's a garden cart with a tarp lining it and filled it full of water, so we'll be able to dunk this in here. And then I have a air regulator set up here. So right now it's just about 20 psi. We can hand adjust this to get whatever pressure we want in there. So I'll go set this up on a tripod and get that dunked in there. Alrighty, here goes nothing. Alright, so we got a leak down here, which is to be expected because that's a threaded port there, so we'll have to make sure to put some sealer on that. The rest of this looks pretty good. Looks like there might be a small leak over here. You got a little pinhole right there, which is why we do this. We'll definitely want to touch up that. Got another pinhole right here. Little pinhole down there, and we got one on this other side, so I'll go grab a Sharpie and mark that, and we'll go back over that with the TIG and then come double check it. So I hope you enjoyed the video building the intercooler. It was something new for me. I couldn't find a whole lot of information online on how to build them or where to get the parts from, so I figured just kind of dig around, and once I found out everything, I figured I'd put it in a video. Put questions, comments down below, let me know. Kind of my first instructional video on this. I'm not a perfect welder, so I don't claim to be, and that's why I don't really go into a whole lot of detail on that. But yeah, this is for this Ecoboost Ranger project. So if you haven't, go ahead and subscribe to the channel. Check out the other videos. Yeah, see you guys later.